guys, in this video I want to talk about the recursion, not just go over the code of it. I want you to know what kind of problem can be solved by recursion and how to write a basic recursive function. So as you know, the recursion is when a function calls itself. So as in the code, it can be public, maybe void, recursive, no parameters, and recursive. Okay, so actually this is one kind of recursion because as you can see in the recursive function body, it just called itself. So let's say another example, which is the factorial. Okay, so this means the factorial of n, which can be calculated by n times n minus 1 times blah 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 until times 1. Okay, so this is the way we calculate the factorial of some integer n. But as we can see, for this part, n minus 1 times blah 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 until 1, which is actually the factorial of n minus 1. So we can write it to n times the factorial of n minus 1. So let's remove this part. Okay, so that's the basic formula for us to calculate the factorial of an integer n. And also the definition of factorial also has the 1's factorial is 1 and 0's factorial is also 1. Okay, so that's all we know for the factorial. And then let's design a function to calculate the factorial. So the parameter of this function, which have only one parameter, which is the integer n, and we have to return the factorial of n. Okay, so it's not hard, and let's write it. So public integer, we call it fac, which includes parameter integer n, and we just first ignore how to implement the function body. We just write the return line first. So return, as we can see, the factorial of n equals to n times n minus 1 factorial. So n times n minus 1's factorial. Okay, we finished. So that's all for this function. However, we have a problem that we don't know what's the factorial of n minus 1. Okay, so I want to introduce a new term to you, which is called wishful thinking. So the wishful thinking stands for you can suppose a function can work before you actually implement it. So in our case, we know what this function fact does. So it just returns, it just gave us the factorial of the integer n, but we didn't write it. We only have its signature and its return line. But have nothing in it. But according to the concept of wishful thinking, we can already use it even we don't know how to write it. So we can use it in here. So this is actually the fact n minus 1. Okay, so as for this step, we'll find that this is actually a recursive problem, because we can say the fact in the fact's body, so the fact function calls itself. So this is a recursion. So this example really tells you that you don't have to know a problem should be solved by recursion, but you don't need to worry. You don't need to worry about that before you actually write it. When you just try to write it, then you'll finally find that this can be solved by recursion. Okay, so once we know this is a recursive problem, then it won't be hard, because we now need to find the base case of the recursion function. Okay, so the base case is here. Okay, so when if the n equals to 1 or n equals to 0, then just return 1. So actually this is the function itself. So as you can see, the most hardest part is the concept of wishful thinking, that I know just someone don't know how to determine whether this function can be solved by recursion, but you can first try to write it and suppose this can work once you have the signature of the function, and then you will know this is a recursive problem once you write it. So thanks for watching. If I hope it can help you a little bit.